Beyond the edge of all sunlight, a tiny, human-made machine is whispering to the abyss. 47 years after its launch, Voyager 1, a probe built before home computers even existed, has done something impossible. It turned back. For reasons no one at NASA can explain, the most distant object ever made by human hands has altered its orientation, turning to face the very system it left behind. It then sent back data so strange, so impossible, that the scientific world froze. What could make a dying probe, billions of miles from home, twist in the dark? And what did it see in the silence between the stars? Launched in 1977, Voyager 1 and its twin, 2, were built to last 5 years. They are now in their 47th. They gave us our first true glimpses of Jupiter's storms and Saturn's rains. Then, they just kept going. Voyager 1 became the first human object to cross the heliopause, the invisible frontier where the sun's influence ends and interstellar space begins. But when it crossed, the data made no sense. The magnetic fields didn't shift as they should have. The plasma density spiked, but the field direction remained locked, as if it hadn't left the solar system at all. Years later, Voyager 2 crossed the same boundary at a different location and reported the exact same anomaly. Two probes, separated by billions of miles, had both hit an invisible wall. NASA's models failed. The heliosphere wasn't a bubble. It was a barrier. The question was, what was on the other side, pressing back? In late 2024, the data stream from Voyager 1 changed. Its cosmic ray detector began registering short, rhythmic spikes, precisely 11 minutes apart. NASA's Deep Space Network logged it as noise from an aging instrument. But the spikes were too perfect, rising in exact correlation with the background plasma. Then came the maneuver. Voyager 1's main antenna, locked on Earth for decades, suddenly reoriented itself by half a degree. The thrusters fired without a command. It was an autonomous, unexplainable act. The probe had turned away from Earth and toward the source of the magnetic flux. When it did, the data stream shifted. The 11-minute spikes merged into a continuous, steady tone. When decoded, it was a harmonic ratio matching the fundamental frequency of the hydrogen atom, the same constant we used to encode the golden record, our message to the stars. This split the scientific community. One camp argued it was a coincidence, a trick of plasma resonance. The other proposed something terrifying. Voyager 1 was hearing its own transmissions reflected back. The data patterns were identical to the probe's own signal profiles from decades ago, but inverted, as if bouncing off a structured, unseen boundary. A reflective membrane at the edge of our solar system. The signal grew stronger for 3 weeks, then vanished. As engineers at JPL analyzed the final packets, they found one last fluctuation, a binary sequence. It matched the timecode of the golden record's very first track. Greetings from Earth. Voyager 1 hadn't just looked back. Something had looked back at it. At JPL, engineers worked around the clock. Filtering the fragmented data, they confirmed the frequency envelope matched one of the probe's original calibration tones, but reversed. Using reconstruction models, they converted the waveform into a 3D spectrogram. What emerged on the screen froze the room. The signal wasn't noise. It had symmetry. 6 repeating spikes formed a perfect lattice, a hexagonal resonance, similar to a crystalline structure. Whatever Voyager 1 had encountered was not a gas cloud. It was an organized boundary, behaving like a membrane. Some called it the interstellar wall, others the mirror. It was behind the probe. It was inside the heliosphere. It was following. That was when the Deep Space Network captured something no one could explain. A second signal, not from Voyager 1, not from Earth, but from somewhere between them. The transmission matched the probe's original frequency, but was stronger, far too powerful to be reflected light or radio bounce. For 19 minutes, it mirrored every Voyager transmission in real time, duplicating its telemetry down to the last bit. It was as though there were two Voyagers communicating, one human, one reflected, separated by billions of km, each echoing the other in perfect synchrony. And then, just as suddenly as it began, it stopped. The data froze. The instruments fell silent. And the only thing left on the carrier wave was a faint oscillation, not in radio, but in the frequency of hydrogen itself. The same frequency used on the golden record to represent the language of intelligent life. In that moment, NASA's physicists realized the unthinkable. The boundary Voyager had reached wasn't the end of the solar system. It was a mirror field, a curvature in spacetime where electromagnetic radiation folds back upon itself. Voyager hadn't found the edge of the sun's influence. It had found the point where space looks back. The gravitational echo wasn't an answer from the stars. It was the sound of our own message being caught and returned by a structure too vast and too deliberate to be natural. And inside that reflection, hidden in the smallest harmonics of the wave, was a timestamp, a countdown measured in seconds. When decoded, the timestamp wasn't a date. It was a duration. A countdown, and its end date aligned with the year 2031. No one at NASA could explain it, but off the record, one scientist described it as a synchronization marker, as though whatever lay beyond the helipause had just begun calibrating itself to our system. "It's not coming toward us," she said, her voice barely a whisper. "It's not aligning with us. It's calibrating to us. And it's using our own probe to set its alarm clock." For the first time in human history, we had reached out far enough into the darkness for the universe to notice, and it had reached back. Voyager 1 remained silent now. Its signal, once steady, has degraded into static that fluctuates every 11 minutes, the same rhythm it detected before turning back. To the public, it's dismissed as a malfunction. But to those who still monitor the deep space frequencies, the pattern hasn't stopped. Every 11 minutes, a faint pulse echoes through the dark. Not from the probe itself, but from the space around it, as though something out there is still repeating our message, waiting for us to send another. So, if this story made you wonder whether Voyager really discovered something at the edge of the known universe, if you've ever felt that maybe our first message into the void was never lost, but heard, don't look away. Subscribe to this channel. Because that 11-minute pulse is still ticking. The silence at the edge of our solar system is getting louder. And when that countdown reaches 0, we may finally learn whether we were the first to say hello, or the last to realize we were never, ever alone.